Welcome to question 9 of the 2009 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For question 9 we're asked to solve the equation 2 log e of x minus log e of x plus 3 equals log e of 1/2. And we're asked to solve that for x. So the first thing we're going to do is we're going to use one of our log laws that says we can take a scalar multiple out the front and put it up as a power. So therefore our equation becomes log e of x squared minus log e of x plus 3 equals log e of 1/2. Next, when we subtract two logarithms, we can simply divide whatever's inside. So therefore we're going to have log e, and we're going to have x squared divided by x plus 3 is equal to log e of 1 divided by 2. Next, if we've got the same base of the logs on both sides, then we can equate the parts inside. So we're just going to equate x squared on x plus 3 is equal to 1/2. And now if we multiply both sides by x plus 3 and multiply by 2 as well, we get 2x squared is equal to x plus 3. So now we're simply solving a quadratic, and that quadratic is 2x squared minus x minus 3 equals 0. So as part of factorising this expression, which is a non-monic quadratic, we're going to multiply the coefficient of x squared, which is 2, by the constant term, which is -3, to find -6. Now what we do is we look for the factors of -6 that add up to -1, and that's the coefficient of x. So we could have 6 and -1, we could have -6 and 1, we could have 3 and -2, we can have -3 and +2. So now when we look at the two numbers that add up to give -1, we can see that if we add the bottom two, -3 plus 2, that equals -1. So these are the two numbers we're going to use to help us factorise this expression. So therefore our expression becomes 2x squared, and we're going to use the -3 and the 2 to separate out the middle term. So I'm going to go plus 2x minus 3x minus 3 equals 0. And if you quickly check, you can see that that's the same expression. We've just expanded the middle term out. And the reason why we've done this is we're now going to factorise by grouping 2 and 2. So if we group these two things together, the highest common factor is 2x. So this becomes 2x bracket x plus 1 is left behind. And then factorising by grouping the next two things together, the highest common factor is -3, leaving behind x plus 1. And of course that still equals 0. And now the highest common factor between these two terms in green and in purple is the x plus 1. So we'll have x plus 1, and then we'll have something that's left behind. And what would multiply by x plus 1 to give 2x times x plus 1 is simply 2x. And similarly, -3 would multiply by the x plus 1 to give the purple term above. And that will still equal 0. So now if we use the null factor law, we find that x could equal -1, and we could find x is equal to +3 on 2. So whenever we solve logs, we've just got to quickly check that the solutions are allowed back inside our original equation. So because we have log e of x in our original equation, we can't have a negative number inside that. So this is not going to be a solution. And that is because log e, when x is -1, is undefined. So the only solution to this problem is x equals 3/2. So from the examiner's report, we can see that a lot of students made progress towards answering this question, with around 22% of students receiving full marks. And the major comment here is that some students incorrectly cancelled one of the x terms in the denominator with the x term in the numerator. So that means that they cancelled across here. And because x is not a common factor on the bottom line, this is not allowed to be done. So we had to go through and solve that as a quadratic equal to 0, like was done on the previous slide.